In this question, it says hexagonal tiles of side 20 cm are used to tile a room which measures 6.25 meter by 4.85 meter. Assuming we complete the edges by cutting up tiles, how many tiles are needed? Let's find the area of the room first. If it says it's 6.25 meter by 4.85 meter, we just need to multiply it. Then we get this in meter square. Now since they're using the tiles in centimeters, so I will convert it to centimeter square before proceeding. So I just multiplied this value of the meter square with 100 and 100 because it says meter square. So in order to get to centimeter square, we know that 1 meter equals to 100 centimeter. So for centimeter square, we just need to multiply 100 twice. Then we get to this value. Sorry, there will be no point over here. That's a mistake. It will be just 303125. There will be no decimal point over here. So now let's find the total interior angles for this hexagonal tile. So the formula to find the total interior angles would be n minus 2, where n is the number of sides, times 180. In a hexagon, we know that there are 6 sides, 1, 2, 3, 4, 5, 6. 6 sides minus 2 times 180, that gives us 720. So this is the total of all the interior angles inside a hexagon. That means each interior angle, each one of them will be 720 by the number of sides. We know that hexagon has 6 sides, so I just simply divided it by 6 and I got 120. So 120 is one angle for a hexagon, and that is that's like a regular hexagon. Since it says it has sides of 20 centimeter, that means all sides are 20. Therefore, all the angles should be same as well. Now, area for one equilateral triangle. If I draw a center and I stretch these lines, this becomes an equilateral triangle. Why it is an equilateral triangle is because if all this interior angle is 120, and if I draw a center and bisect the angle with the radius of that, then of course if the value will be 60, because half of 120 is 60, so 60 will be on this side as well. So if this is 60, this should also be 60, as this is the center and these are the radius. The base will be equal. If the radius are the same, then the angles opposite to those should be same. So this is 60, this is 60. That leaves us with 60 on this side as well, because we know that in a triangle the sum of angles is 180. So if I get the base, the sum of angles at the base is 120, that means the remaining angle should be 60. And from that I got to know that this should be an equilateral triangle. If all the angles of a triangle are 60, it has to be an equilateral triangle. So to find the area of one equilateral triangle, we will be using this formula, which is half AB sine theta. So half times A, which is 20, B is also 20, sine 60. That gives us this value. So area of the regular hexagon, which is the whole thing, we just need to multiply this value with 6, because there are 6 triangles, 1, 2, 3, 4, 5, 6, 6 of them, and we got this value. Now we need to find out the required number of tiles which is needed to fill up this room, to tile this room. So previously we found the area for the room. Now we found the area for one hexagonal tile. So if we divide the area of the room with one tile, one area of a tile, then we can find out how many tiles is required. So we got 292 tiles, which is required to tile this room. You can also use these formulas to find the value of an area of an equilateral triangle. So for an equilateral triangle, if you know that it's an equilateral triangle, the formula is root 3 by 4a square, where a is the side of a triangle. As you can see, I used the value 20 as it is at 20, and it comes down to the same value, 173.2. Over here it's 173.2 as well. For the regular hexagon, there is a formula. It is 3 root 3 by 2 a square, where a is again the length of a side. So 3 root 320 square by 2 gives us the same value as this value.